Now let's continue. Let's do that question. May 2019 question 4C. May 2019 question 4C. So the same sitting question 4, you are told that highlight two differences between transportation and assignment model in linear programming. And we say that under transportation is that one source can supply to more than one destination. Another difference, we say that for transportation, it's not necessarily a square matrix. Then under assignment, we say that under assignment, a source can only supply to one destination. Also, a destination can only receive from one source. And also we say that an assignment is a square matrix. So kindly go through that. Let's go to part C. The table below shows the number of years of experience of 10 salesperson and the respective mean monthly sales realized by the salesperson. So we have salesperson 1 to 10 years of experience, and we have mean monthly sales. Required the coefficient of correlation, and then we interpret the results. Then number 2, using ordinary least square method, predict the mean monthly sales that would be realized by the salesperson having 15 years of experience. So now this being a forecasting and correlation question, 1, you need to identify the independent variable. What explains the other? So in this case, you need to determine your X and your Y. So in this case, you have the year of experience and we have the mean monthly sales. What do you think is your X? What explains the other? What do you think is your X? So in this case, your experience will express your monthly sales, but your sales cannot explain your what? Your years of experience. So where you have the years of experience, write X. Then mean monthly sales is your Y. So how do you solve that? So you have your X, you have your Y. So your X, we have said that is the year of experience. We have 6, 4, 2, 10, 7, 4, 6, 7, 12, 8. And then we have Y, 180,000, 150,000, 80, 500, 90, 100, 200, 220, 600, and 200. Then we determine your XY, you determine X squared, and then you get Y squared. So I showed you the easier way is to use a calculator. So let's do that. Let's do that. Then you add the total. So summation of X is 66. Summation of Y, you have this is 24, 20. Then we determine summation of XY. which you have is 20, 110,000. Then summation of x squared, you have it's 514. Then summation of y squared, this one you have it's 8, 458. 1, 2, 3, 1, 2, 3, 1, 2. Yeah, so that's what we have. So let's answer part 1. So I've computed the summation of everything. So it's not necessarily that you have to show those figures, provided you know how to use a calculator. We say that you can write this using a calculator, where you insert the formula x, comma, y, m plus, like that. So number 1, you want the coefficient of correlation, that's r. They say that to get r, it's n, summation of x squared minus summation of x, summation of y, divided by n, summation of x squared minus summation of x in bracket squared. You multiply by n, summation of y squared minus summation of y in bracket squared. Then all of it, you get the square root. So n, we had 10 salespersons. Then summation of x squared, we have the summation of x squared, which is 514, minus summation of x, which is 66. You multiply by summation of y, which is 2420. Then you divide by, and then it's not necessarily that for y, you have to write 180,000. You can also work with thousands. You just take 180, 150, 80, 500, exactly. It's not a must that you have to work with those big numbers. So n we have is 10. You multiply by summation of x squared. So how much is that? Summation of x. Sorry, this one is supposed to be summation of xy. Summation of xy, sorry. And summation of xy we have is 20, 11, 10, like that. So summation of x squared is what we have, it's 514, minus summation of x. Summation of x was 66, then you square. All of it, you multiply by n, of which n was 10. Summation of y squared, we have it's 84, 58 billion. And then you minus summation of y squared. Summation of y was 2420. Then you square, and then you get the square root. So what do you get that? You do like that. You'll have r is equals to 0.92. R is 0.92. So how can we interpret that? We say that if correlation is in between 0 to 0.29, between 0.3 to 0.69, 0.7 to 0.99, we say that we have a weak correlation. Here we have a moderate correlation. Here we have a strong correlation. But if you have positive or -1, that means there is a perfect correlation. But if you get an exactly 0, that means there is no correlation. So in this case, we have a correlation coefficient of 0.92. That means there is a strong correlation, a strong direct correlation between the year of experience and the cells. So we can say that there is a strong direct or positive correlation between experience of determination. In case the examiner wanted to get the coefficient of determination, which is denoted by R squared, you could have taken 0.92 and then you square. In case you were to get the coefficient of determination, you could have gotten 0.85. And how do you interpret the coefficient of determination? We say that coefficient of determination shows how the dependent variable is explained by the dependent variable. So in this case, we can say that 85% of the monthly sales are explained by the years of experience, or we are 85% sure that the sales, the mean monthly sales are explained by the year of experience. That's when the coefficient of determination is required. Let's answer part 2 of the question. Part 2, you're told that using the ordinary least square method, predict the mean monthly sales, least square. Under least square, y is equals to a plus bx, where b, it's n summation of xy minus summation of x summation of y divided by n summation of x squared minus summation of x in bracket square. And to get a is a summation of y minus b summation of x, you divide by n. So let's determine b. You take n was 10, multiply by summation of xy, which is 20 and 10,000, minus summation of x was 66, multiply by summation of y was 2420. And then you divide by n, which is 10. You multiply by summation of x squared. Summation of x squared was 514. And then you minus summation of x, you square. The summation of x was 66 squared. So what do you get as your B? Shift number 2. Then you pray forward and you'll get 52,781. And then how do we get A? To get A, you take summation of y. And how much was the summation of y? Summation of y, we had 2420. Minus B, we've gotten our B as 52,781. Then you multiply by summation of x, and summation of x was 66. You divide by n, n was 10. So what do you get as your A? A you are getting is negative 106, 350, 352. Good. So now let's come up with that equation where y is equals to A, our A is minus 106, 352 plus bx, our B was 52,781x. That's the least ordinary square function. So how can you use it to predict? So y will be equals to negative 106, 352 plus 52,781. So now let's go to the required. I told that now. Using the ordinary least square method, predict the mean monthly sales that would be realized by the salesperson having 15 years of experience. So is that you multiply by x, and in this case, x, which is the year of experience, is 15. So how much will be your monthly sales? And you get 685, 363, 363. So 1 minute, you take a screenshot of that. Let's try another question. September 2015. September 2015, question 2B. And you're told that a marketing firm employs part-time marketers. The hours worked and the earnings of 10 such marketers are shown below. So you have marketer 1 to marketer 10, hours worked, and then the earnings. So in this case, they were very specific. They give you what was X and what's Y required. The least square regression function relating to hours worked and earnings. And then we interpret the results. And then number 2 is the Spearman's rank coefficient correlation. Then you comment on your results. So let's start with the least square. So you have your X, Y, you determine X, Y, X squared. Since they don't want the correlation coefficient, you don't have to get Y squared. So then we need to get the summation of XY and then X squared. So you can use a calculator or you can do it manually. So summation of X, it's 394. Then we get summation of Y. Summation of Y, it's 94.2. Then summation of XY, you have it's 4192.5. And then summation of X squared, it's 17,898. Then with that, we need to use the least square where Y is equals to A plus BX, where B, it's N summation of XY, summation of X, summation of Y, and summation of X squared minus summation of X in bracket square. So just take N, they were 10 marketers, you multiply by summation of XY, And the summation of xy, we have it's 4192.5. Then you deduct summation of x, which is 394. You multiply by summation of y, and summation of y, it's 94.2. Then you divide by n is 10. Summation of x squared, we have summation of x squared, which is 17,898 minus, you take the summation of x, then you square, and summation of x was 394. 394 square. Therefore, your B will be and you have 0.20. Now with B, we can get A. And how do we get A? Is a summation of y minus B, summation of x over n, of which it will be summation of y 94.2 minus B, which 0.20. You multiply by summation of x 394, all of it you divide by n, which was 10. So what do you get as our A? And A we have 1.438. So that means y is equals to A plus bx. That means our equation will be y is equals to A. A is 1.438 plus bx. Our B we had was 0.2, 0.2x. And then you write that your figures are in thousands, or remember your y was in thousands. So it's the same as writing like this. Y is equals to, convert this one into 1,000. So it would be 1438 plus 0.2x. Now note that when you're converting this, it only affects the fixed element. It does not affect the variable element. Good. Good. And in this case, now this is how we interpret. So let's be here. In case you are taught to interpret this equation, though I might struggle, that's when we'll be doing ANOVA. In this case, remember our y, what was y? Was earnings. And then x was the number of hours. So we can say that this 1438, this is the change in y, and in this case, our y is what? Earnings. This is the change in the earnings due to other factors not in the model. That's what it means. Then this coefficient of x, which is 0.2, this is the change in y. Are we together? When hours worked is increased by 1 unit. In this case, we had only 1x. So for example, if you're having a multiple equation that y is equals to A plus maybe 0.4x1 minus 0.6x2 plus 90x3, assuming you have an equation like that, and then you're told to explain that equation. So what you usually do, you look at the coefficient 0.4, 0.6, 90, and then A. So A is our constant. So we say that this is the change in y. So assuming in this case, our y is the, we can say, yeah, production cost. And then, yeah, so you can say that A, for example, our constant was maybe was, you are given a certain figure, like for example, it's 40. You say that this is the change in production cost when due to other factors not in the model, because that's the constant. If you have 0.4x1, you say that this is the change in production cost when factor x1 is increased by 1 unit. If you get a negative, we say that this is the decrease in the production cost when factor x2 is increased by 1 unit. Then this 90 is positive. You say that this is the increase. So this 90 is the increase in the production cost when factor x3 is increased by 1 unit. That's how we interpret a forecasting equation. Good. Let's answer part B, part 2 of the question. Part 2. Part 2, you are told that the Spearman's rank correlation coefficient, Spearman's rank. We say that under Spearman's rank correlation, you need to get to rank. You look at the relationship between the ranking of various variables. So in this case, we had marketers. Marketer 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have your X, you rank them. Then you have your Y, you rank them. And then you get D squared. And we say that D is the difference in ranking. So X, we had 20, 30, 48, 39, 28, 14, 60, 50, 62, 43. Then Y, that's the earnings. We had 5.5, 7.4, 11, 9.3, 7.2, 4.3, 13.5, 12, 14, and 10. So let's rank. Let's start with X. And the highest rank we have is 62. That's rank number 1. Number 2. Then we have number 3. Number 4. Number 5. Number 6. Number 7. Number 8. Number 9. And number 10. Also, now let's rank Y. We rank Y. Which one has the highest? We had 14. That's rank number 1. Number 2. Number 3. Number 4. Number 5. Number 6. Number 7. Sorry. Interchange here. From number 4, this was number 5, right? Number 5, number 6, number 7, number 8, number 9, number 10. Let's get D. We say that D is the difference in ranks. So for example, this is rank number 9, this is the rank number 9. The difference is 0. 0 squared, you still get a what? 0. 7 and 7, the difference is 0. 4, difference is 0, 0, 0, 0, 0, 0, 0, 0. And the total is, even without computation of Spearman ranks, you see they were the same in the ranking. So that means there is what we call the perfect correlation between the ranking. Are you together? So remember, I said that to get the Spearman's rank, it's 1 minus 6 summation of D squared over n squared minus 1. So it will be 1 minus 6. Summation of D squared is 0. You divide by n. There were 10 marketers. 10 squared minus 6 times 0 is 0. 0 divided by all that still be 0. Eh? So it's 1 minus 0, still get what? 1. So that means there is a positive or direct correlation between, we had hours worked and earnings. Between hours worked and earnings. So you can take a screenshot of that. So on the same sitting, I want us to do question 5B. That's September 2015, question 5B. It's on time series. So we are told that the data below represent the sales made by Pengo traders for the period of 3 years. So we have quarters 1 to 4 and year 2013 to 2014. Required the centered moving averages, average trend values. Number 2, seasonalized additive indices. So that means you are using the additive model. And then number 3, you get the deseasonalized time series. Part C of the question, you are to highlight 4 components of time series. And what are the components of time series? Number 1, we said we have secular trend. We have the cyclical. We have random or erratic. And then we have seasonal variation. Good. Those are the components of time series. So B, now let's present that. We're using the additive model. So we have the years. Then we have quarters. Then we have oranges. And oranges, that's the actual data, we call it A. Then we get 4 moving averages. Once you get the 4 moving averages, you center them. You get the centered averages. That's what you call T. Then, once you get the centered average, you get what we call the estimated variations, or what you call the estimated indices. From there, you adjust them. You get the adjusted variation, and then you get your deseasonalized data, which is denoted by Y. So we have year 2012, quarter 1, quarter 2, quarter 3, quarter 4. 2013, quarter 1, quarter 2, quarter 3, quarter 4. And 2014, quarter 1, quarter 2, quarter 3, quarter 4. Then we have the actual, or the number of oranges. 2.2, 5, 7.9, 3.2. 2013 quarter 1, we have 2.9, 5.2, 8.2, 3.8. And then 2014, quarter one, we have it's 3.2, 5.8, 9.1, 4.1. So now let's get the four moving averages. We say that to get the four moving averages, you take the first four. That's 1, 2, 3, 4. You add the total. Once you get the total, then you determine the average. You divide them by 4. And then you put them on the center point. So the center point between 1, 2, 3, 4 is in between 2 and 3. So that's why you have your 4.575. Then you drop the first one. You pick the next 4. So you take 1, 2, 3, 4. You add. And then you divide by 4 to get the average. And then you put them in between. So in this case, it will be there. You have 4.75. Then you drop the second one. Then you take the next 4. So take up to that point, like that. Then lastly, you take the last 4. You have 5.55. Now, if you drop that one, you only remain with 3. So you ignore the rest. So once you have the 4 moving averages, now you can get the centered averages. And how do we get the centered averages? You just center the 4 moving averages. You take the first 2, then you get the average, and then you put in between them. So in this case, you take 4.575, you add 4.75, I've added the 2, then you get the average, and then you center it. So you have 4.66. Then you drop the first one, you center the following 2 or the next 2. So it's 4.75. You have 4.775. Then you take 4.8, you add 4.875. Then you center them, and you have 4.84. $4.95. $5.06. Good. So now we have that. Once we have the centered average, now let's get the estimated variations. Now to get the estimated variations, when using the additive model, just take A minus T. That's the actual minus the centered averages. So for example, the first one, you take 2.2 and here you have a dash, so ignore that. The second one will be taking 5 minus dash, you ignore that. Then the third one, you take 7.9, you deduct 4.66. You have 3.24. Then for you take 3.2, you deduct 4.775. You have negative 1.575. You have it's negative 1.94. You have it's 0.25. Negative 1.375. We have it's negative 2.16. (0.29). Then we have dash dash. So that's how we get the estimated variations. Then let's get the adjusted variation, which is our seasonal variations. That's our S. How do we get our S? To get our S, we say that you come up with an analysis table. Analysis table S. How do we get that? So we have your years. We have your 2012, 2013, 2014. Then you get the average, and then you adjust your average. So then you have your quarters, quarter 1, quarter 2, quarter 3, quarter 4, and then you get the totals. So together, this is adjusted. We are getting the adjusted variation. And we said that to get the adjusted variation, use the estimated variation. So in this case, from our analysis table, we are extracting the information from the estimated variation. And we start with the year 2012. Year 2012, the first quarter, we have a dash. Quarter 2, we have a dash. Quarter 3, we have 3.24. Quarter 4, we have negative 1.575. In 2013, quarter 1, we have negative 1.94. Quarter 2, 0.25. Quarter 3, 3.14. And quarter 4, we have negative 1.375. Then 2014, quarter 1, we have negative 2.16, 0.29, then dash dash. So let's get the average. So for example, in quarter 1, you take 1.94, you add 2.16, and then you divide by 2. You have negative 2.05. In quarter 2, you take 2.5, you add 0.29, then you divide by 2, get 0.27. Quarter 3, do the same. Get 3.19. Then quarter 4, you have negative 1.475. So can you add the total averages? Add the total averages. If you add the total averages, you are getting negative 0.065. But remember I said that when using the additive model, the summation of the seasonal variation should always equal to 0. So we need to adjust. How do you adjust on that? So we get the adjusted or the normalization value. So from negative 0.065, it needs to increase to 0. So that means to increase, you have to add 0.065. Yeah, if you take negative 0.065, you add 0.065 should equal to 0. Then this normalization value, you divide by 4. So you spread it across. So here, that means you add 0.02, 0.02, 0.02, 0.02. That one is exceeding, or you can do this, because if you round off 0.02.2, that's equal to 0.8. You can just do this 0.2, 0.02, 0.02. Then this one you can call it 0.1, and this one 0.1. There is a very small difference. So here you have is 2.03, but a negative. I have 0.29. Here you'll have 3.20. And here you'll have 1.465, but a negative. So what we get as our adjusted variation, that's what we bring in our analysis table. Every quarter one, we have its negative 2.03. All the quarter ones for each year, it's negative 2.03. All quarter ones. Here we have it's 2.03, a negative. Then all quarter two from the adjusted table, 0.29, 0.29, 0.29, 0.29. Quarter three, we have is 3.2, 3.2, 3.2, 3.2. And then lastly, quarter four, we have its negative 1.465. 1.465, negative 1.465. That's how we get the adjusted variation. And lastly, we get the deseasonalized. To get the deseasonalized data, when using the additive model, you take A, that's the actual data, minus the adjusted variation. So it's A minus S. Take A minus S. For example, the first one will be taking 2.2, you deduct negative 2.03. So, and what do you get? So in that case, you get it's 4.223. Then the second one, you take 5, you deduct 0.29, and you get 0.4. Is it 47? Sorry, it's 4.71. Sorry, should be 4.71. Then the third one, you take 7.9, you deduct 3.2. You have it's 4.7. So that I was supposed to present. So we can take a screenshot of that. November 2020. Question 4C. Question 4C. November 2020, question 4C. And they say that under the analysis table, when using the additive model, the summation of the seasonal variation should equal to 0. But if you're using multiplicative model, should equal to what? Should equal to 4. Good. So November 2020, question 4C. So you are told that the data given below shows the profit in shillings, millions made by the economic sector in your country during the various quarters of a given year. So you have year 2016 to 2019. Then we have the profits in quarters. Required 3-quarter moving averages. So the 1 3-quarter is not for quarters. Cool. So how do you get 3 quarters? So we bring the years here. 2016. Then quarter, you have quarter 1, quarter 2, quarter 3, quarter 4. This one you don't have to leave a gap. 2017, quarter 1, quarter 2, quarter 3, quarter 4. 2018, 1, 2, 3, 4. And then 2019, 1, 2, 3, 4. Then your A, or the actual information given, it was the profits. So 2016 quarter 1, we have what? We have 83. We have 260, 215, 293. Then quarter 1, 105, 383, 248, 553, 140, 430, 323. So we have 588, 168, 543, 340. We have 755. Then we are required to get 3 moving averages. So you get 3 moving averages. We see that when getting the 3 moving averages, you just take the first 3, then you get the average. So let's do that. 83 plus 260 plus 215. What you get, then you get the average by dividing by 3. Then once you get the average, 1, 2, 3. Where is the middle point? The midpoint will be the second one. That's why you put your average 186. Then you drop the first one, you take the next 3. So it will be 260, you add 215, you add 293, then you divide by 3, and then in between the second, the third, and the fourth, the in between is where you have 3. So we have 256, like that. So we have 204. We have 260. we'll be having is 245. There we have 395. 314. 374. And then the last one will be dash. And the first one still will be dash. That's how you're getting your 5 marks. Then let's go to part 2 of the question. Part 2, you're told that the decisionalized profit for the economic sector using the additive model. So how do you apply this to get the additive model? Now, this is what you'll do. When you're using the 3 moving averages, we don't center them. We don't center them. So that means you go directly to the estimated variation. And to get the estimated variation in this case, you'll be taking your actual profit, A, now minus the 3 moving averages. So let me call it B. So it will be A minus B. That's how you get the estimated variation in case you had a 3 moving averages. So you'll be taking 83 minus dash, ignore that. 260 minus 186, like that. So let's do that. The last one will be dash. So that's how we get the estimated variation. Then to get the adjusted, nothing changes. To get the adjusted, in that case, you come up with an analysis table. Analysis table S. So here's quarters. So you had here 2016, 2017, 2018, 2019. Then you get the average. Then we adjust so that we get the adjusted averages. We had quarter 1, quarter 2, quarter 3, quarter 4, and then we have the totals. Yeah, we are still using the additive model. So we say that to get the adjusted variation, we use the estimated variation. And 2016, quarter 1, we had dash 74, 41, 89. Then 2017, we have negative 155, 138, minus 147, 239, 234, 163, minus 124, 28, 252, John is negative here. 252 is a negative, eh? Negative 252, 166, negative 183, dash. So let's get the average. You get the total, then you get the average by dividing by 3. You're not dividing by 4, is by 3. So this one you get is 213.67. It's a negative. Then the second one, they were 4, so divide by 4. We have 135.25. 41, you add 147, you add 124, you add 193, then you divide by 4. You get 126.25. Raster 89. You add 239, 28, then you divide by 3. You're having, so this is negative 118.67. So with that, let's add the total. We add the total averages. And you're getting negative 86. That's the total. But we say that when using additive model, the summation should give you 0. So that means since we have negative 86, we wanted to increase to 0. So that means we have to add backward 86. So then you take 86, you divide by 4 so that you spread. So that means you'll be adding 21.5 in each. So here we have it's 192.17. Here we have it's 156.75. We have it's 104.75. $140.17. So now with that, let's get the adjusted. So every quarter one will be having its 192.72. Quarter two, it's 156.75. Quarter three, 104. So this should be negative, eh? 104.75 are negative, and quarter four we have it's 140.17. Quarter one is start again, 192.17 are negative, 156.75, negative 104.75, and then quarter four we have 140.17. So quarter one again, 192.17 are negative, 156.75, 104.75 are negative, and quarter four it's 140.17. 2019, so quarter one we have it's 192.17 negative, we have 156.75, then we have 104.75, last we have 140.17. And now with the adjusted variation, now you can get the deseasonalized. So how do we get the deseasonalized? So nothing changes. You take the actual data, you multiply by S, the adjusted. So for example, the first one, this is what you do. You take 83, you minus negative 192.17. So let's do that. 83. You get 270. 275.17. The second one, you do the same. You take 260 minus 156.75, get 103.25. 215, you'll get 319.75. 293 minus 140.17. Yes, now that's what you are supposed to do up to the last point. So you can take a screenshot of that. So let's try the last question. December 2010, question 1A. December 2010. Question 1A. It's a question on exponential smoothing. So you're told that the data below shows the monthly share price of Exert Limited for the year ended 30th November 2010. So we have the months and we have the share price. The share price forecast for the month of December 2010, that's what's required for December. We need to forecast for December using exponential smoothing. So we need to forecast for December. Still a forecasting. And you are told that use a smoothing constant of 0.3. We see that under exponential constant, to forecast, that's ft plus 1, usually take ft, and we see that ft is the forecast for the current period. Then you take at minus ft, you multiply by alpha, or you take alpha at minus ft. This is the error. We see that at minus ft is the error made, and then the alpha is the exponential constant with the probability of something happening. And we say that the first one for December, that one becomes that one does not change, it will be 80. Then we forecast for February. We say that for February, you take ft, which will be 80, plus 80. We said 80 is the actual for the previous period. So the actual for the previous period, we are in January. So previous period was in December. So we take 80 minus ft. This is what you bring here. This ft is what you bring there. So it's still 80. And the probability exponential was 0.3. I'll still get what? 80. Then for February, you take 80 plus 80 is the actual for the previous period. In February, the previous period was in January, which was 76. And then this 8, you bring it here, 0.3. So that's 4 times 0.3 is 1.2. And then you have 81.2. Then for March, you'll take 81.2. You add, the actual for the previous period was 78. So you take 78 minus 81.2. So you get 3.2. So 3.2 times 0.3, and then 81.2 minus the answer. And you get 80.24. So in April, so you'll take 80.24 plus, actually for the previous period was 82. So you take 82 minus 80.24, you multiply by the probability. You'll be having 80.77. Then you have 80.77 plus 80 is the actual for the previous period, which is 72, minus 80.77 multiplied by 0.3. You have 78.14. So here you'll be having 78.14 plus 82 minus 78.14, 0.3. The first one. The second one. This one. This one. That one is 80 point. This one. That one is okay. This one should be. Yeah, actually it was you're supposed to deduct. Actually this one is wrong. You're not supposed to add 1.2, you're supposed to deduct. So it's 80 minus 1.2. So it's supposed to be 78 point. Yeah, 78.8. If that changes, it will change this. So that means this one will be 78.8. Then you take 78 minus 78.8, 0.3. and you'll have 78.56. So this one will be 78.56 plus 82 minus 78.56. We have 79.59. So take 79.59 plus actual for the previous period, in this case will be 72 minus 79.59, 0.3. We'll have 77.31. 77.31 plus 82 minus 77.31, 0.3. Have 78.72. 78.72 plus 68 minus 78.72. So that's what you have up to November. Now the question was you forecast for December. Can you forecast for the December? So for December it will be 75.5. You add, what do you add? You add 82 minus 75.5, 0.3. And you'll be getting 77.45. So you can take a screenshot of that.